Hi, last week we started with 5.1 pet sitters, and some of the information that we were given is that we had 360 square feet available to set up some cat pens and some dog pens. We knew that cat pens took up 6 square feet of space and dogs took up, where's the dog pens? 24 square feet of space. And so we needed to come up with a combination of either all cats, all dogs, or a combination of both that would fit that 360 square feet. In addition, we only had a certain amount of money, and so dog pens cost $80, while cat pens, they were a lot cheaper. They cost $32. We had a total of $1,280 that was available for us to spend. And so if we had all dog pens, how many could we buy? If we had all cat pens, how many could we buy? And then if we went up here and we decided that we wanted some dogs and some cats, what combinations of pens would work? And that was, we took it back over to the back of our book. And a lot of you were supposed to draw your cat pens and dog pens here. And so if you had 6 feet available, there's maybe a 2x3 that would represent one cat pen. And you would keep going until you had the number of cat pens and dog pens that would satisfy your space requirements and would satisfy your money requirements. And so everybody's should have looked a little bit different. Could have done all cats, could have done all dogs, or any combination of each. This week's task is too big or not too big. And Carlos is considering the amount of money available, and he realizes that his father's suggestion of boarding the same number of cats of 12 and same number of dogs doesn't work, okay? And so you need to figure out why. And so you're going to have to go back and say, hey, if I had 12 cats and 12 dogs, would that not work because of the money, or would that not work because of the space? All right? And you're going to kind of work through these questions. There's a lot of vocab in this section, like constraints. You were supposed to go into our task above where it said learning targets, and you were supposed to look up the vocab ahead of time, and that will help you with these vocabs that are in bold, like solution set and satisfy. And so if you are having trouble with those words, go back to the previous assignments and look up those vocabs, and you were supposed to write those in your journal. Also email me if you have questions. But for 5.2, we are going to also be using the grid in the back. And so I want you to come over to the back here, and this is where we're going to be doing our constraints. I want you to put cats on the y-axis, the number of cats, and I want you to put the number of dogs on the x-axis. All right? And so we're going to be comparing cats versus dogs, and we're going to need an appropriate scale. We're always going to start at 0, 0. And you're going to be going up by an even number for your dogs, and then an even number for your cats. I know that cats are probably going to go higher if you are having your constraints. My suggestion, I think, would be 10 per cat, but you can decide on your own. And I would probably maybe go by 4s for dogs, 4, 8, 12, 16, 20, maybe 2s. I'm not sure. Depends on how many dogs are available. 3, 6, 9, 12, 2, 4, maybe 2s. Right up here, we have a table. So we're going to be writing inequality for our startup costs and inequality for our startup space. We haven't got to this yet, so you are going to ignore feeding time and pampering time right now, okay? You're going to be writing down your intercepts, which is maximum dogs if you had no cats, okay? Well, our cats is our Y, and our dogs is our X, so it's going to be written as an ordered pair. If I had 0 cats, how many dogs would I be able to have for my startup costs? And then here we go, maximum cats, no dogs. So if I had 0 dogs, 0 X's, how many cats could I have? All right, and I want you to do this in a key color. So your startup costs might be blue, your space might be green, your feeding time might be red, and your pampering time might end up being yellow. All right, if we come back over to here, for example, I'm going to help you write your startup cost. Okay, we know that cats are 32 and our cats per Y. Okay, $32 per cat pen. And it's $80 per dog pen. And we said that dogs are our X's up here. So we have $32 per cat and $80 per dog. And we can spend, that has to be less than or equal to that $1,280. Okay, that $1,280. So we have $32 per cat and $80 per dog, has to be less than or equal to that $1,280, and that's our inequality. You're going to do the same thing with your space, except for cats take up less space, plus how much your dogs take up has to be less than or equal to the total number of space you have available. And then here's where you're going to write your ordered pairs of your cats and dogs. So if I had all cats, or all dogs, no cats, all cats, no dogs. And once again, I want each of these to have a specific color, and then you are going to graph it here. So you're going to find the maximum number of cats for your startup cost. If I had all cats, so if I plugged 0 in for my dogs, how many times can 32 go into 1280? And that's going to be my maximum number of cats. Boop, I'm going to put a point there. And then I'm going to do the same thing here. If I had all dogs and 0 cats, I'm going to plug a 0 in here. I'm going to plug these intercepts in. How many times does 80 go into 1,280? That's going to be my maximum number of dogs. That's going to be down here. Then I'm going to connect it with my specific color. All right, I hope this helps.